name is Haroon Rashid, and I have vast experience of teaching O level and A level, and now I'm offering online group tuitions in O level subjects like mathematics, additional mathematics, physics, and chemistry. The good point in online group tuition is that fees is affordable to all. In this video, I'm giving an example of online class in chemistry, and I'll follow the same format in other subjects. The main part of this video is lecture. The first part is lecture plus explanation. Second part is examples where required. The third part is practicing from past year papers. And in this part, I'll ask my student to solve the questions in their copies and discuss the same question with me on Zoom during the class. And again, I repeat, the purpose of this video is just to show you format of an online class. Let me start from O level chemistry. I'm choosing a topic which is methods of purification or separating techniques. And before I discuss, I want to clear a few things. What are elements? An element contains only one kind of atom. For example, the element iron contains only iron atom. So if you take iron, for example, it is made up of only one type of atom, that is atom of iron. There are other elements like carbon, like sulfur. They are only made up of one type of atoms. Compounds. A compound is made up of different elements, and these elements are bonded together chemically, and we cannot separate the constituent of elements by any physical mean. For example, you can take water. The formula for water is H2O, where hydrogen and oxygen are in the ratio of 2:1. It's a fixed proportion, and the ratio between hydrogen and oxygen is always 2:1. The constituent hydrogen and oxygen in water cannot be separated by any physical mean. We can take any other compound. For example, we can take carbon dioxide. Ratio between carbon and oxygen is 1:2, and this is also fixed. You cannot change it. And then come mixtures. A mixture contains different substances that are not bonded together. They are not chemically bonded together. That is why you can separate constituent of mixtures by physical mean. I can give you one example. You can dissolve salt, common salt, in water. This is a mixture. The constituents can be in any proportion. I can take 2 grams of salt with 1000 grams of water, or I can take 20 grams of salt in 1000 grams of water. In both ways, I get a mixture. It is not a chemical compound because they are not chemically bonded uh, during this. Constituent of mixture can be separated, and we have different methods for separating constituent of mixtures. And here we are discussing this in methods of purification. The first method is filtration. You can see we use filter paper in this method. We use filter funnel, and we can take an example for this filtration. As I said, filtration is used to separate a mixture of a liquid and an insoluble solid. So you can take a mixture of sand and water. Sand is insoluble solid, water is a liquid. And if you put this mixture on this filter paper, then water will pass through the filter paper and can be collected as filtrate, while sand is deposited as residue. So this method of filtration is used to separate insoluble solid and a liquid. Crystallization. Some solids exist as crystals. For example, copper 2 sulfate exists in the form of blue crystals. And if I take a solution of copper 2 sulfate, which is also blue in color, and I heat it and heat till I get a saturated solution, then on cooling I get crystals of copper 2 sulfate. So in crystallization, we simply heat a solution to saturation point, and then on cooling we get crystals. For example, we can get blue crystals of copper 2 sulfate by this method. Then comes sublimation. Some solids sublimate. They directly go from solid to gaseous or vapor state without passing through the state of liquid. And examples of such solids include iodine, naphthalene, and there are other examples. So sublimation is used to obtain a solid that sublimes from a solid mixture. Solids can sublime include iodine and naphthalene. Suppose I am provided with a mixture of sodium chloride and iodine, minded that iodine can sublime while sodium chloride will not. So if you heat the mixture, you will get vapors of iodine, which on cooling give you solid iodine. Separation using a separating funnel. A mixture of immiscible liquids that have different densities can be separated using separating funnel. I can give you an example. For example, oil and water are immiscible. By immiscible, I mean they cannot be mixed together. So in that case, you can use separating funnel and separate them very easily. The funnel look like this, where you put the liquid, and Liquid with higher density will go to the bottom, and liquid with lower density will be at the top. Like if I'm taking oil and water, then oil will come here and water will come here. And since the two are immiscible liquids, so I can separate them using this separating funnel. Simple distillation. Distillation is used to separate a liquid from a mixture. For example, we can obtain water from salt water using this method. And here let me point out water is the solvent since it is in greater quantity, and salt is solute. So both solute and solvent combine together to give you a solution. So by simple distillation, we can separate solvent from a mixture. So if you look at the diagram, here is the salt water, we are heating it, and this is a condenser, you can call it Liebig condenser. And remember the water in and water out position, it's important for examination point of view. And if we heat this salt water, we get water over here at 100 degree centigrade. And since salt is a solid, so it will remain in the beaker, and you get purified water in the beaker. Then come fractional distillation. This method is used to separate a mixture of liquid with different boiling points. For example, we can separate a mixture of ethanol and water this way. This is an example. But there could be two or more liquids, but they should have different boiling points. Suppose I have a mixture of three liquid A, B and C, and these three liquids have different boiling points. Then I can use this method of fractional distillation to separate the three liquids from the mixture. Now this is the diagram. You can observe a fractionating column over here. A fractionating column allow liquid with lower boiling point to escape first, and thermometer will give you the temperature, and liquid with lower boiling point will escape first, and the condenser will condense the vapor to liquid form. So in the mixture of ethanol and water, ethanol has lower boiling point, somewhat 78 degrees centigrade, and water has higher boiling point, 100 degrees centigrade. So you will get ethanol first at 78, and water will come after that. So also remember that when ethanol is coming here, the temperature will stop at 78 degrees centigrade, and it will not rise until all ethanol is collected, and then then temperature begin to rise and you will collect water. Paper chromatography. This method can be used to separate a mixture of substances. It can also be used to identify substances. The separation is based on the difference in solubility of its component in a particular solvent. I'll explain it in a while. RF value is the distance traveled by component divided by distance traveled by solvent. Now let me clear first few things. Chromatography paper is a filter paper. It has pores inside, and I'm using black ink to clear the concept of chromatography. This is a solvent in which this black ink is soluble. Mostly inks are water soluble. So I'm taking water over here, and this level of water should be below the dot, black ink dot. Now by capillary action, water will rise up and will dissolve this black ink, and this water keep on rising till it reach some point near the top. Now if you take out this filter paper or chromatography paper out from here, you can spot 3 dots, A, B and C. So we can conclude that this black ink is made up of A, B and C type of dyes. And why A is near the bottom and C is near the top? Because if a dye is more soluble, then it will rise greater distance, and less soluble one will remain close to the bottom. This RF value is, as you will understand when you do examples in past year papers. Right now you just learn the formula or keep it in mind that RF value of any dye, any component, is distance traveled by the dye divided by distance traveled by the solvent. Distance traveled by the solvent is this distance. In examination, we're supposed to use ruler if the diagram is given to us. I'm solving an example. It's a past year paper question. The diagram below shows the result of an experiment to identify the components of mixtures X and Y. Each mixture is known to contain one or more of the single substances L, M and N and P and no other substance. So we are provided with X and Y, a mixture of X and Y, and we have to detect whether L, M, N or P are present in the mixtures or not. So we take drops of the single substances as well as the mixture, and this is the starting line, and we use capillary tube or dropper to collect the dot. Then we put this whole thing in a solvent in which all these are soluble, and the solvent should be below the starting line. So the solvent will rise up due to capillary action, as I told you, and you get different spots. Now let me read the question. What name is given to this experiment? And it's chromatography. Draw a line on the diagram to show the solvent level at the beginning of the experiment. The solvent level should be below the start line. So this is the answer for B part. You can draw a straight line. Part C. What piece of apparatus does the student use to place spots L, M, and P, X, Y at the start line, on the start line? So we use capillary tube to place the dot. We can use dropper also. Part D. In this experiment, the substances L, M, N, and P are not colored. Mind it, if they are not colored and they are colorless, then we use locating agent. You don't have to name the locating agent, but it is in the form of spray. If you spray it, the colorless dot become colored. So they are asking what name is given to a substance which will change L, M, N, and P into colored spots, that is locating agent. Writing locating agent is sufficient. Use the diagram to deduce which of the substance L, M, N, and P are present in mixture X and mixture Y. So let me check mixture X first. Go back to the original picture, original figure. You can see this X contain M because this dot and this dot both are at the same level. The mixture X also contain P, they both are at the same level. Mixture X contain N because you can see the two dots are at the same level. So what you will write, you will write M, N, and P. Now come to mixture X and let me use some other color. Now I'm going to mixture Y. See, mixture Y contain P, this. Mixture Y contain L because these dots are at the same height. So only two dots. So the answer is L and P. So after this, I will go to past year paper, which is not possible right now because I have no class at the moment. But during the class, I will make my students do these past year paper questions. I will show them the diagram, or if they have their own past year paper books, then they can sort out the paper because the years are written. And I give my students 5 to 10 minutes or some good sufficient time so they can try these questions and discuss on Zoom. And this discussion is very important. It is a very important part of learning, because when you apply your knowledge, then only you learn things properly. So there are different techniques in past year paper, and you can see I have multiple questions covering different dimensions. We can include more questions depending upon the response of students. So that's the end of this online class. The purpose of this online class is to give you a demonstration how the online class will be conducted, and this is only chemistry, while I offer tuition in mathematics, additional mathematics, and physics also. And I also give face-to-face tuition at my place in DHA Phase 6, Karachi.